All right, welcome back, class. This video we're going to make is on equivalent ratios. I'm going to do the first part of the video, then an old friend of mine is coming in to do the second part of the video. So equivalent ratios. They are ratios that have the same value, meaning they have the same number value. There might be different numbers, bigger numbers, smaller numbers, but at the end of the day, they mean the same amount of stuff. We have two different methods to find if ratios are equivalent. I have one easy one down here. If we have 2 dogs to 1 cat, that's the same or the equivalent ratio of 4 dogs to 2 cats. There's 2 different ways to figure this out. We're going to look at a couple of harder problems. The first one we're going to look at, we're using method 1, which is finding the unit rate. All right, method 1, finding a unit rate. Everybody in my class by now should know to find a unit rate, we need to make sure the denominator is 1. Find the unit rate. It is a rate or a ratio where the denominator is 1. We all know that from our last chapter. So we're going to go to a little bit of harder problem. Instead of two dogs to 1 cat or 4 dogs to 2 cats, we're going to look at money. One person makes $10 for every 2 hours of work. $10 for every 2 hours of work. Next person is making $30 for 6 hours of work. We need to figure out if these are equivalent. So in your book it might ask you, are they equivalent? Okay, step 1. Step 1 will be find the unit rate for both sides. Find unit rate for both sides or both ratios. All right, we have $10 over 2 hours. How do we get 1 in the denominator? That's what we have to ask ourselves. And if we look here, how do we get from 2 to 1? Well, it's going smaller, so we have to divide. What do we have to divide 2 to get 1? It'll be 2 divided by 2 gives us 1 hour. Whatever we do to the bottom, we need to do to the top. So 10 divided by 2 gives us $5. So the first unit rate is $5 per hour. Let's look at the second unit rate. $30 over 6 hours. Same concept here. We need to get to 1 hour on the bottom. We're finding the unit rate. We get from 6 to 1 using division, and we're going to divide by 6. Divide by 6. Whatever we do to the bottom, we have to do to the top. So we are dividing 30 divided by 6, which gets us $5. Step 2. Step 2 is very simple here. Step 1 is the mathy part. We already have the math part done. $5 an hour and $5 an hour. Those are our unit rates. Step 2 is figuring out if they're the same. These are the same. Obviously, $5 an hour and $5 an hour are the same. They are equivalent. If they were not the same, then they would not be equivalent. Let's assume that this was $6 an hour and this one was $5 an hour. They are not the same. They are not equivalent. So if you're good at finding the unit rates, this would be a method for you. Second method, which my friend is getting ready to come in and show us, will be a slightly different way, but it'll still get you the answers. Hello, humanoid 6th graders. I am the masked mathematician, and I'm going to help you wrestle with math and get it down to the ground. Today, we are going to talk a little bit about equivalent ratios and my favorite method, the second method, using equivalent fractions. I know Mr. Jameson taught you the method to find the unit rate. That's all well and good, but this is what I want to do. We're going to talk about an example here using equivalent fractions. So our example we're going to use for using equivalent fractions. I have 7 wins. I win all my matches, but out of those 7 wins, I had 3 pinfall victories, or 3 pins. My next round of matches, I had 14 wins. No losses, just wins. 14 wins and 9 pins. So we need to figure out if my ratio of pins to wins was the same or was equivalent. So step one, we need to look at the numerators. How do we get from one numerator to the other? We go from 3 to 9. That is going up. 9 is bigger than 3, so we have to use multiplication. 3 times 3 equals 9. And remember the rule, whatever you do to the bottom, you got to do to the top. And whatever you do to the top, you got to do to the bottom. How do you get from 7 wins to 14 wins? It is times 2. Step 2, denominator. Denominators. Look at the denominators. 7 to 14. 7 times 2 equals 14. Step 3, compare. We're going to look at the numerators and the denominators. If they are the same, if you do the same thing to get from one to the other, they are equivalent. If you do not do the same thing, if it's something different, as different as me and Mr. J, it is not an equivalent ratio. So on top, we did times 3. On the bottom, for the numerator, we did times 2. Not equivalent. This is not an equivalent ratio. If it was an equivalent ratio, you would have the same method to get from one side to the other for the numerator and the denominator. You don't have that, so this is not equivalent. Your example that you have to have for tomorrow. You have 12 pinfalls out of 30 wins. 12 pins out of 30 wins. And you have 48 pins out of 120 wins. Are they equivalent? Are they equivalent? So you get down on that mat, you wrestle with that math, and you tell me, equivalent or not. See you tomorrow, brother.